This recording is about a project that you need to do for this course. Let me explain the project. As you know, when we talked about rectangular regions, like double integrals over rectangular regions, so we had a rectangular region. Let me show it R, and this rectangular region X ran from like A to B, and Y was running from C to D. And these numbers for the rectangular region, these numbers were given. The other way to do this is using technology. And the whole point of the project is using technology for doing double integrals or this kind of double integrals. And I'll explain how we use technology to approximate the double integral of a function. This is usually done for more complicated functions. And for simplicity, I assume that that rectangular region is actually a square. So suppose a function is given, and in the project, there will be a specific function. But for now, let me show it as f of x and y. And this region R consists of all x's from 0 to 1, and y's are also from 0 to 1. This is a square. This rectangle is a square. So let's see what in the xy plane, what a square is that. So in xy plane, it's going to be this square. If I want to estimate this integral, I can divide this square into partitions. Suppose I make it into 4 squares. So I make it into 4 equal squares. Of course, if I make it into 9 squares, I'll get a better approximation for the integral. If I make it into more partitions, more and more, we get better and better approximation, and the limit of all of these will be equal to the actual value of the integral. But let me go with this 4 square partition of the region. So I have 4 small squares. From each of them, I pick one number or one point. Like, for example, from this square, let me pick one point. Eventually, at the limit, it doesn't matter which point we have chosen, but in the estimation, it does. For simplicity, let me choose the upper right corner of this square. And obviously, this point, as you know, is point 1/2, 1/2. From this square, I choose upper right corner, which is this point here. This point obviously is the point 1 and 1/2. From this square, I choose this upper right corner, which is point 1/2 and 1. And finally, from the 4th square, I choose this upper right corner, which is point 1, 1. So the area, the value of this double integral is approximated by this value. The value of the function times the area of the rectangle, and I should add up for all of these 4 rectangles. Let me write it down here. Since it's just 4, it's not complicated to write that down. So I will have for the first square that we had, f of 1/2, 1/2. So I find the value of f at that point, multiplied by the area of that square. Obviously, the area of that square is 1/4 because each side is 1/2. Then add it to the second one. I should evaluate f at 0.1 and 1/2 and multiply it by the area of 1/4. I do the same thing for the other, so I should add up. I continue here. Plus f of 1/2 and 1 times the area of 1/4 plus f of 1 and 1 times the area of 1/4. If I add up these four terms, by these four terms I mean these plus these plus these plus these, I get an approximation of the double integral. Of course, if I make it into 9 small equal squares, I will have 9 terms, and each of those numbers, those fractions, instead of 1/4, each of them will be 1/9. As I mentioned, when we increase the number of those partitions, we get a better approximation. And here is the project that I want to give you. And that project is we want to have estimate this double integral e to the power of xy over region. It's a square shape. X is from 0 to 1. Y is from 0 to 1. And I want to make 25 partitions, meaning that if on the xy plane, 1, 1. So when I make it 25 partitions, the very first, obviously the very first square is going to be somewhere like here. And of course, there are 21 squares like this because it is 20 partition of 25 squares. And for each, so I need to add up 25 terms. Just as a hint, for the first square here, I consider the upper right corner, which is the point 1/5, 1/5. So I should the first term is going to be e to the power of 1/5 times 1/5, because that's the function, right? Times 1/25. Plus, if I go this way, the second square is going to be this square. Now, this time, the upper right corner point is going to be point 2/5 and 1/5. So x is 2/5, y is 1/5. So it is going to be e to the power of 2/5 times 1/5. I'm using the function e to the power of xy. Then it's multiplied by 1/25. And of course, there are 25 of them. Of course, I don't expect you to write all of them by hand. Instead, what's the purpose of this project is you can use any technology, any software that you think that it works. The department, as you know, this project is a requirement by the department for this course. And the department recommends using MATLAB for this. But any comparable software, as long as it's you can find the value of this, will work. And in the announcement, I'll explain that how you can submit the result of the project.